Hey, I hope you guys can hear me okay. I'm calling from my shop. You can see it's winter. I've got my heat source for now in my shop. My heat source is this propane heater right here. It's very effective. Takes a little bit to get started, but she does warm it up pretty good. Anyway, this is where I spend a lot of my free time. It has been a long time coming. But in order for this to be a proper shop, what I had to make sure was that I wasn't running off of a single extension cord run from the corner of the house, which is pretty much how I built this place. One single electrical cord. It owes me absolutely nothing. But what I've got in place now is a power source, thanks to the school loaning me a generator, and I'll show you that in a minute or two. But I've wired up the entire shop to give me all the electrical outlets that I am going to require to run my shop once I tie it in permanently to the house. Now, how I tie that in permanently to the house, we'll talk a little bit about in this video. But what I wanted to talk about first was how this whole shop is wired up. Now, I've done it using something called BX cable. Now, come on, I'll show you what that looks like. BX cable is this stuff right here, okay? This wire right here, this metal coated, spiral coated wire. It's an armored cable, or BX. People in the industry just refer to it as BX. You can get a bunch of, there's a variety of different sizes of wire. Consider wire like a hose that you send electricity through. And the electricity is, well, think of it like water. The more water, the bigger the wire. If you send too much electricity through a small wire, now we're just going to cover the basics because we don't have time to go into detail, but if you send too much electricity through a wire, several different things could happen. If it's wired up properly and you're asking far too much out of your electrical wiring system, then the electrical breaker, the circuit breaker in your fuse panel is going to pop. Okay, we'll talk about that in this module as well. But what I really want to talk about is the size of the wire. Say your electrical fuse panel doesn't blow a circuit. Well, if you send too much electricity through your electrical wires, they get hot because literally the flow of electrons in the wire is friction, right? So it generates a lot of heat. Too much heat, the wire breaks. Then you get an arc, or it gets too hot and it melts the casing on the inside, because inside this armor casing are wires, and the wires are coated with an insulating material like plastic or rubber or whatever. If it's too hot, melts that. Then you've got an electrical circuit being connected inside this casing, and well, you know what? You don't have to know a lot about electricity to know that when you get electrical circuits arcing out or shorting out, instead of going the entire length of the wire to the electrical fixture and back safely, it loops around inside a place where it's not supposed to, short circuiting. Well, that's kind of where the phrase comes from, a short circuit. The circuit isn't complete, it actually shorts out. It can short out to itself, short out to you if you touch the casing and you get a shock. Well, needless to say, the type of wire that you use is extremely important. The thickness of the wire matters a great deal. Anyway, there's an awful lot we could cover, but let's back it up just a bit. I've got a power supply. Let's start there. I'm going to show you what our power supply is. I used to have an electrical cord, like I said, running to the house, but now what I've got is a generator. Now I've got that generator running with two electrical cords that run under the shed and out and over to what I have as a temporary electrical panel, which there are no electrical breakers, but there are circuit breakers for safety on that generator. So the power supply over there, if I ask too much of that power supply, that will kick off. Simple. It's a safety feature. That's what circuit breakers are. They're a safety feature. So what I've got right here is where the electrical lines come in. The two cables come in and they go into this electrical box. Now I've had to put a double box on it because there's a lot of wires that are coming and meeting inside these octagon boxes, and that's what those are. They're metal boxes. Let me show you what another type of electrical box is. It is a metal box these little washer type things, these little knockouts, they pop out and the electrical lines go in. You have a fixture like so that fastens the wire in place so that the cables, the electrical cables, when they're moving around here, they don't get kind of cut on the edge right here. So that they have little fixtures, little devices to hold the wire in place in a safe way. Then the electrical connections are made inside the box. Woo. The electrical connections are made inside the box. The electrical wires are then tied together, not just with electrical tape, with these. These are called wire nuts, or in the industry they call them Moretz, because that's the brand name, Moretz. They've got a coil of a conductive material inside. It's like a copper spring that goes down to a funnel. And when you put the 2 wires or 3 wires together, you twist this on and they actually thread onto each other and it holds it in place. And you just tighten it up. You can fasten that in place permanently with electrical tape. But that's how you make a very quick electrical connection. But it's very important how you do it. You've got to make sure that they're actually not going to come apart inside the box. Then you'll have loose wires. Not a good idea. So what I've got is I've got all the electrical power coming in to this box right here. Now don't worry, this is only temporary. And what I've got... All right, everybody. Sorry, we had a little bit of a mix-up there. Ran out of storage on the phone, had to clear it up. So what I was saying was, I've got the generator outside. It feeds into my makeshift little hub right here. Nice and safe, it's nice and insulated and well connected. But then from there, I branch off 2 different areas. I branch off one line that runs along this wall where I've got 2 electrical outlets. Very simple. The electricity runs in a loop. The black hot goes out. It connects to all the electrical outlets. On the other side of the electrical outlet, there's a white common that comes back, just making that loop. And there's a copper line that runs inside, which is a ground line. We'll talk about that too in just a little bit. So basically, it's a loop. Picture a hose that has water flowing through it. Wherever you plug in a sprinkler, it makes the sprinkler go around, right? But remember, water is a great way of explaining how electricity flows. And there's a video that is attached to this little package that explains that. It's about 2 or 3 minutes, and it's very informative. So I've got one line going out there, one quick loop. But I've got another line that goes up and it feeds a heater, it feeds a ceiling fan, feeds a light, then it snakes over across the top, it drops down to feed the electrical, not the electrical, but the air filtration unit, which you can take a look at that right there. There's that big box that's hanging on the wall. It's really cool. I like it a lot. And then 2 electrical outlets that are down beside. Now, that second feed has a switch attached to it that's turning on and off the light upstairs or up on the ceiling. It also has, along the way, it has a electrical outlet that is in line with it. So in order to make sure you've got things branching off here, branching off there, doing it safely, you have to have what they use is a wiring schematic. Now, I had an electrician next door, so when I laid this whole thing out, he gave me the once over and said, yeah, that's good. And I really tapped an intelligent resource. It was brilliant. So understand how the electrical systems are laid out in your residence is very important, because especially with electricians or the electrical trade, if they make a mistake, there's some people who could get killed. It's no lie. Electricity is nothing to guess at or nothing to mess with. You may in your life very shortly or in the not too distant future put in your own electrical outlets. You may run an electrical line from point A to point B, but it is so easy to make a huge mistake because you just didn't know. Don't underestimate how much knowledge is required in this field. So there are some stories that I've heard and I've seen. You pop your head up into a house that you bought and there's electrical lines that are run, but they're actually extension cords. Old extension cords, or you buy a house and it's an older system that people have tied new electronics to. It's just, it doesn't work. It's nothing to mess around with. But let's take a walk back, and we're going to walk back to the house and we're going to see, you've seen how my shop is powered by that generator. Now, what I want to talk about is, I'm going to turn my heat source off here, head back inside and get a hot chocolate. So I'm going to turn my power source off. Now what we can do is we can talk a little bit about the sources of electricity, and we go into more detail in that with that in grade 11 and grade 12. All right, so I just shut down my power plant. What we've got here, what we're going to talk about is, well, look up in the trees there. You can see directly above me the electrical line that ties into the pole that delivers the electricity to the house. Now, some people in newer neighborhoods, they have their hydro lines. We call it hydro because in these areas, a lot of our electricity comes from the generation, or the power generated by hydroelectric plants, which basically means waterfalls, Niagara Falls, haha. We'll talk about that in grade 11. So the wire comes in, ties into the house. You can see how it's tied in up there, right? Up at the top, right about there. Where is it? Right about there. Comes down through that plastic tube. Now that plastic tube has a very specific name. You remember the armored cable that was out in my shop, the BX. Now that protects the electrical lines that are running throughout your residence, or those you'll find them a lot in commercial applications. They want to leave them exposed, or they want to just throw them. They can take a beating, but they'll keep the electrical lines inside safe. This plastic piping comes in a variety of different sizes, from very, very small to quite large. This is about a 2-inch pipe, and it's called a conduit. Conduit is a word that's used to describe a vessel through which something flows. Piping is a conduit of water. This is a conduit for electrical cables. So it protects it from UV, okay? And what they do is they'll run the conduit where they want the wires to go, and then afterwards, using a vacuum, they'll hook a vacuum up to one end of the pipe, and they will suck they will use it like a straw, but they'll suck a string that goes all the way through it. One end will have somebody holding onto the string. The opposite end, they'll tie it to a rope. They'll pull a rope through. Then they'll tie the rope to the electrical cables, and then they'll pull the cable through the conduit. It's a way of doing it, in stages. But anyway, the electrical line comes in through this conduit down to what we have now installed in St. Thomas, are smart meters. Now, these smart meters tell you exactly how much electricity you've used, at what time, and for how long, and then they can charge you. Not so long ago, they got off of the system of telling you that they'll charge you this much at this time of day and a little bit less at this time of day, but because of COVID, everything's got messed up, and now they're charging us 12 cents a kilowatt hour. And well, that's something we can go into detail at a later time. But needless to say, that little device right there is how my electrical bills are calculated. They'll tell me how much I owe them for using the power that I use. So things have come a long way. After that, now we're nice and toasty. Now, what we've got, let's travel through the house. That's my daughter making lunch. Alrighty, we're heading downstairs. Because most of the time, your electrical panel, if you have a basement in your house, one of the 4 styles of foundations, what you have... Sorry, I'm going to just set up the... setting up the tripod here. This is a bit of chaos. Maybe I'll edit this video and take that out later on. So what we've got here... So you're downstairs in my basement. Alrighty. You know what? I'm not going to edit this. This will be live. Whoo! Off comes the jacket. I'll get some of that interior heat. All right. So what we've got here is where we hide our electrical panel. In our basement, we've got this electrical panel hidden behind a piece of artwork that my wife has made. Oh, and don't mind him. That's Bart. Bart Ender. Get it? Anyway, here's our electrical panel. Now, I'm not going to be doing much with it. I'm just going to show you what's inside. But from outside, those main power lines come in through the top. You can see the top right there. There's that 2-inch pipe, that conduit that went from the power lines on the poles outside, across the sky in my backyard, to that conduit, down the conduit to the meter, where they calculate my bill. And then from that meter, goes out the bottom of the meter, in through the inside walls of my house, and over to the top of the main bus of my electrical panel. Now, I'm lucky because I've got 200 amp service. I've got 100 going here, 100 going here, because my house was built in the 60s, and there's a lot of electrical requirements back when this house was built for the person who owned it. So I'm fortunate I have 100 amps to deal with. Now, that's a whole conversation we can have later. I don't want to bog you down with that. But needless to say, this is what happens. The main line comes in here where there's a main power shutoff, okay? Whoa, very scary. Very scary. 200 amps. That is crazy. All right, so I'm going to close that up because I don't want to be in there. I don't want to be in there at all. I'm not going anywhere near that. But the power comes in here if we've got this main shutoff. Boom. Each additional panel on the side has 100 amps, and there's some electrical current that flows to this side. And then from here, all these individual wires are heading off to the bedroom, the bathroom, all these different places. One to the garage, out to the back where the pool pump runs. And inside here, you can see all these little electrical switches. This is the sub panel. Okay, so if I want to shut the power off to the garage workbench, click there. This is the electrical breakers. These are the electrical breakers. Now what these electrical breakers are, the electricity comes in, goes through the electrical breakers, and then out to wherever that room is. If I do something that asks too much electricity, the wires would melt if we didn't have these electrical breakers going, whoa, that's too much electrical flow. Click, and it shuts off. Now, there's a couple of ways that those breakers work. We won't get into detail about that. I just want you to understand how the flow works, how the whole system is laid out. So the electricity comes in from the pole, down to the meter, down to the main bus, over to the sub panel, through the electrical breakers, and then out into each of the individual rooms. Electricians have to understand how all this stuff gets put together and what requirements or what is required in each of the rooms. So they say, whoa, so this is going to the bedroom, it's going to need this much wire and this fuse panel. So they lay out the whole system, and they know what's required. Where do you think they figure out where do they get all the information to do their jobs correctly based on what's required? The Ontario Building Code. And they're taught the Ontario Building Code and how to implement the rules and regulations in there through their apprenticeship. And they work side by side with somebody who knows, and they come to understand how everything is put together. They learn one little piece of information at a time. They know that a bedroom has to have this type of wiring. It's got to be, all the codes change all the time, but they have to have color coding wires. They have to have certain breakers that go here, there, and everywhere. When you're in a bathroom, if there's water splashing around, where you're plugging your hairdryer in or whatever, then you'll have to have something called a ground fault circuit interrupter, which we'll also talk about. Anyway, that's pretty much the rundown of what I wanted to show you, how the electrical system in a house is put together. Hopefully you enjoyed it. I like my shop.